So from the behavior of the trajectories in parameter space, we can now infer the behavior of, say, x as a function of time. And again, just to remind you of what the nullines look like, we had the two nullines. This was x dot equals 0. This was a nullline, y dot equals 0. Along the horizontal, x is changing very rapidly, whereas y is barely changing. In the crawl, when I'm crawling along the nullines, then both x and y are changing relatively slowly. So if I look at x as a function of time, that translates to the following kind of a picture. So there is a time scale that's of the order of 1 over mu, where I crawl along the nullline, x doesn't change by much, and then I hit either one of the two inflection points of the nullline, and then x changes suddenly over a region which is of the order of 1 over mu. So it's easy then to integrate these equations of motion of the van der Pol oscillator and see this very beautiful behavior that becomes more and more pronounced as this control parameter mu gets large. So as mu gets large, there's a separation of timescales between the horizontal part of the trajectory and the crawl part of the trajectory that gives rise to this very non-harmonic behavior for the van der Pol oscillator.